Hello, and welcome to this tour of the web interface of Red Hat Advanced Cluster Security for Kubernetes. I'm Chris Porter. I'm a solution architect for ACS at Red Hat. We're going to start here using the web interface. There are other interfaces to ACS, including command line and API, that we'll address in other videos. But today, we're just going to strictly use the web user interface. So I've used my browser to navigate to the central endpoint for my deployment. Here, I'm using Red Hat Cloud Service for ACS that gives me an endpoint in the cloud managed by Red Hat. I'm going to use the Red Hat single sign-on here because I'm using my redhat.com account to authenticate as an administrator. In your environment, you may see something different here with other SSO options created by your administrator. Logging in is as simple as providing credentials for your Red Hat account, in my case, just a simple email login. Once that's verified and logged in, you should see the ACS user interface. You start at the dashboard. The dashboard for ACS is a one-stop shop for an overview of your security risks in your environment. There are configurable widgets here that link to additional information. So for example, when I look at images at most risk, the View All button here will take me to an images list to show me all of the images in my environment. The dashboard widgets are customizable. If I have preferences around what I want to see, all or fixable vulnerabilities, for example, in the images at risk widget, I can change the selections here, and the dashboard will re-render. As we drill down into each of these sections, most of these dashboard widgets have a corresponding menu on the left-hand side. The left-hand side menu is the primary means of navigating the product here. And if you're familiar with the OpenShift dashboard, you'll be familiar with this here. Each security use case has its own separate section, whether it is the network graph for network segmentation and network threats. It could be violations, which refers to policy violations here. The compliance scanning page, which refers to hardening and other regulatory standards for configuration of OpenShift and the workloads running on it. You'll see here that vulnerability management is, as of this recording, has two separate sections, a 2.0 and a 1.0. And here you're witnessing a transition between an older version, which is still functional and complete, to a new version, which is still in tech preview. As you drill down further, you'll see that each page has a different interface. Options for drilling down, for example, using drop-down menus on the top right. Many pages have an additional detail when you click in the list. So here, for example, the risk page looks fairly quiet, but as I click on items in the risk page, you'll see that the right-hand side populates with data. Pages like Network Graph work in the same way. The last menu down here on the left-hand side is the platform configuration menu, where I administer the product. Now, depending on your login credentials, I'm logged in here as an administrator. I see all of the options, but you may not. Ordinary users that are looking at security results, analysts who are in a read-only mode may not see all of the options and may not be able to change the settings here. So the administration menu covers quite a bit, from the addition of clusters to be secured by ACS, to the main policy management page, to what we call collections for defining the rules that associate namespaces and deployments with certain known workloads. Integrations, which is where we configure ACS to talk to other products, whether it's the purpose of communicating with image registries for pulling down image data and layer data, to cosigned signature keys for validating cryptographic signatures of images, to notifiers. Notifiers are an important topic, one that probably justifies its own video here. But notifiers are important for sending security data to external tools like Splunk SIM, email or Slack or Microsoft Teams for human notifications, or other systems like Ansible event-driven architecture servers for the generic webhook. You'll also see things like authentication tokens that allow the API to be used, or cluster init bundles used to deploy ACS on additional clusters. Another big topic for the user interface that I've hinted at is access control. That your view of the user interface is going to be dictated by the roles, which include permission sets and access scopes. Again, this is a big topic, and RBAC and single sign-on will have its own video. But here, you're looking at the default set of roles that ACS ships with that we can assign to users and groups. So these roles are designed for what we consider to be typical tasks: the full administrator accounts that I'm logged in as, the analyst accounts that allow you to read only, or specific machine tasks like continuous integration and sensor creator. These are used for automated systems to give a minimal level of access that's required in order to do things like deploy ACS components or use the command line tools in a CI/CD tool. There are some additional options here to look at in the system configuration. These are documented, and the settings by default are pretty solid. You won't generally need to change much like data retention periods, but they are available here. Lastly, in the cloud environment, I have administrative events that gives me access to an error log for anything that might be occurring. Here, for example, I'm seeing that ACS is unable to retrieve certain images. And so as I investigate and resolve these issues, the administration events page can be very helpful. The system health page then gives me a summary of some of the capabilities of the product. Here you can see that I have my clusters in a healthy state, and this is obviously what I would prefer to have, which is all of my components are running and checked in with the control plane. I do have an image integration error that I have to fix. I have certificates that expire more than almost a year out, so I'm good there. But this is a one-stop shop for understanding where issues might be occurring that I can address. There is also ability to generate a diagnostic bundle. If you're working with Red Hat support, this is a great way to provide the support team with information about the running state of the product. And in fact, you might be asked during an engagement with Red Hat support to create and download a diagnostic bundle. Let's go back to the dashboard here and dive a little bit deeper into the functionality provided here. You'll see at the top bar that I have a kind of readout of my environment here. I have a single cluster connected. ACS is a multi-cluster product, so I can certainly connect other OpenShift or other cloud platform Kubernetes clusters to this. Within that one cluster, I have 6 nodes. These are the virtual machines that run RHEL Core OS. I have 203 policy violations. This is a great place to get started. You'll see that reflected down here as well. Out of that 203, 7 are considered critical, meaning that they're high scoring, high risk, justify immediate action. And then there are, of course, high, medium, and low. These policy violation severities are dictated by the policies in my platform configuration. So they don't necessarily reflect vulnerability severity, but they do represent a security risk. As I click on each one of these, I'll be driven to a place where I can see more about that. Here, for example, I can see that I have an old Apache Struts vulnerability present. That's a critical policy violation, as well as a critical severity vulnerability. I have the log4shell remote code execution vulnerability present in my environment. I have the more recent rapid reset. So these are critical vulnerabilities in applications that are deployed on my cluster. Here we can see at the bottom one where there was actually some enforcement action taken by ACS. By default, ACS does not enforce these policies, and so the 6 at the top here are simply noting the fact and maybe sending out notifications, but they're in inform mode. Whereas the last one here showed me that we actually enforced this. We prevented the deployment of an application because the image it uses has this remote code vulnerability in it. Back on the dashboard, all of the drill downs here give me a quick glance. If I'm looking at compliance, for example, I can drill down into let's say the OpenShift PCI DSS controls. I'm given all of the checks created by, in this case, the compliance operator. And just like some of the other pages in the UI, as I click on each one of these, more detail will appear on the right-hand window pane. So for a lot of the UI pages where you don't see the immediate detail right away, clicking on the items in the list is going to bring that detail up. Some pages, like Network Graph, require a selection of workloads before I start to see results. So here in the Network Graph, I have a set of drop-downs at the top that will give me access to that. I only have one cluster here called production, but I have a number of namespaces here. So this gives me the way to click to select the particular namespaces, environments, and you'll see that the graph re-renders as we go. Again, more interface becomes available when I click on workloads in this space or namespace here. It's a little subtle, but it will show you the namespace wide or the deployment level, in this case, connection data. So the graphs in the arrow here show me the direction of traffic. The little boxes show me the port and protocol. There's a legend here for all of the icons shown. The network graph presents a lot of information. There's potentially a lot of screen crowding here, and so you have the ability to filter this tightly. The icons are there to indicate some of the more urgent need to investigate issues like my wide open traffic here. The network graph also has a right-hand side menu that pops up when I click on an individual component. The network graph shows me active traffic. The active flows are considered for the time period specified up here in the upper left. So as I shift this, you may see the traffic lists and the graph re-render to reflect the time frame that I have selected. When I have a time frame like that selected, it also impacts what we call the network policy generator to determine the active traffic used to feed that the policy generator. Before we get to that, though, we can tour through the details of this particular deployment. I can link to the port configuration, the container configuration. Here you see, for example, I can see the underlying container image that was used and some of the resource requests and the use of storage and secrets. I can also look at the active flows. So if I want a list of what traffic has been seen, what directions, what port and protocol, every deployment running in the environment tracks that. I can also choose to be notified about what we call anomalous flows. Anomalous flows are those that have occurred outside of the baseline. So every deployment in Kubernetes is examined by ACS. That examination includes tracking all of the runtime network connections that the pod makes. That establishes a baseline, a normal set of behavior that we don't expect to change. Anomalous flows represent a flow that has changed, something different about this. This could indicate a threat. It could indicate that a container has been compromised, that someone is attempting to move laterally from pod to pod, and then potentially to exfiltrate data. I can use that baseline as a way of enforcing rules. Now, ACS uses Kubernetes network policies. Here you can see that I don't have any, and that's the problem here, that I'm not filtering traffic in any way. There's a more detailed video on this subject, but the network policy generator allows me to generate network flows policies to restrict those flows based on the baseline. So clicking on this here gives me the output of Kubernetes network policy code that would restrict the traffic to the workflow, the baseline flows that we've seen. Another feature of the network here is we call listening endpoints. This is an informational page. It allows you to search and filter and to drill down on the binaries, the actual executables running with inside deployments that are listening on ports. Think of this like a netstat type of tool, but for entire clusters and multiple clusters that ACS is securing. I can look at the process ID and the ports that are open here to understand, for example, when I have a Java Java interpreter running a Java program listening for connections out there. And this is true regardless of what type of binary this is and what it's running. You'll be able to see all of these that are open. The port and protocol here doesn't necessarily mean that these are open to the world or even open within the cluster because additional services are required. It just shows that the container does have those ports listening. Let's take a look at violations. Violations represent individual events where policy criteria was matched by either runtime or vulnerability or configuration matches. Policies are made to look for critical vulnerabilities, bad practices, any place where we're deviating from Kubernetes recommended hardening, or in this case here, we're looking at runtime activity that potentially indicates a threat. This indicator of compromise is classified that way because we're running Netcat. Now, Netcat is a harmless network utility, but it can be used in a malicious way. And so when we see network utilities, system utilities, file transport tools, developer tools running in a container, that violates the general practice of containers that should be small, self-contained, and have no impact on the configuration of the container there. And so we highlight these as part of the risk. Again, ACS does not enforce rules against anything by default. You have to change those policies to intervene, but they do provide a good overview of risk and an understanding of your environment and what's running within it. Policy violations, like any page, can be filtered, so we can look for specific deployments. We look at everything. So you'll see here both custom workloads in your environment as well as workloads that come from third parties, from parts of the OpenShift environment. ACS is designed to provide visibility into anything that's running in those clusters that would potentially be a target for attackers. The next page here is compliance. As I said earlier, compliance is focused on regulatory and industry compliance, hardening standards like CIS. In this case, we've integrated ACS with the Red Hat compliance operator that provides profiles, for example, for the OpenShift 4 hardening standards from the CIS benchmark. Here again, you'll see that as I click on these individual items, I'm given the control guidance. This comes directly from the profiles of the compliance operator. The other configuration standards here reflect more workload compliance. I can drill down and certainly look at something like PCI compliance, for example. PCI is focused on isolation of cardholder data, appropriate protections and authentication for cardholder data. And you can see here that we're measuring the status of network policies on deployments. So this is focused on workloads. For that reason, this overview is, I think, less compelling than looking at, let's say, a per namespace or per deployment level. So if I am interested in, a storefront application here in their PCI compliance, you can drill down into the individual namespaces and then into the individual deployments as well. So for example, if I want my currency service to meet PCI standards, I can actually drill down to that individual deployment level and understand that, here, for example, section 1, which in PCI is concerned with firewalls and isolation of cardholder data, that I'm not meeting the standards today. One thing to note about compliance is also that you'll see a prominent export button here as well. The export button allows me two options: either to download the page visually with the graphs, the bar charts, and the rows charts here as a PDF, or the evidence file as CSV. This is an exhaustive version output in a spreadsheet format that shows me the details of every control applied to every applicable object and the results and pass-fail and the reason for that pass-fail. So as I'm looking to actually achieve compliance with regulatory standards, the evidence gives me that capability to show those controls in place. Vulnerability management is a very, very detailed set of results of the vulnerability scanning of all images. There's a separate video on this topic to show you some of the capabilities here, but as a brief overview, you can drill down and understand the details of any vulnerability, old or new, low or high, severity. All of these are part of the platform's UI here to show me that I have issues to fix. These are going to be continually updated against new CVE data. I can drill down into images, into deployments. I can pivot through this data in a number of different ways. I can also manage things like watched images, which is images that I want the system to maintain vulnerability data for, even if there's the image isn't in use. Vulnerability reporting is a way of building and sending scheduled reports. These are configured here to provide, say, periodic updates. I can send these out via email or just have them downloadable. The downloadable ones here give me the ability to download that spreadsheet directly to examine it. This can cover any scope. It can cover all vulnerabilities, just selected vulnerabilities. It can only be delivered. It should be delivered to teams. These are configurable in the UI here, where I can create new vulnerabilities. The 1.0 dashboard here still has functionality that's similar to 2.0, just arranged a little bit differently. So you'll still see the same familiar image data here, just arranged slightly differently. In this, the current video recording, at the time of the current video recording, one of the UIs here that has not been able to, not been moved to the vulnerability management 2.0 schema is the risk acceptance UI. This is coming soon. Risk acceptance means that I have decided to defer or for a time period or permanently a vulnerability in the environment. And this is something where there's a sophisticated set of functionality here. I can actually, as an administrator, I can choose to defer or in other words, to silence warnings about a given vulnerability for a period of time or indefinitely. I can also allow my users to request those deferrals and grant some administrator privileges to be able to review and approve those. The configuration management UI is an overview of the infrastructure that is running here. So this is details about clusters, nodes. It's much more focused on what is the platform running, the security of the platform itself, rather than the security of the workloads in the platform. So as you see here, I can drill down at the level of clusters and namespaces or to nodes. Here you can see the 6 nodes in my environment, including the masters and the workers. That gives me details about the version of the kubelet, the kernel version, the node operating systems. Here, for example, I'm running RHEL Core OS, which is the operating system for OpenShift. If I were running Amazon EKS, I would see Amazon Linux here, for example. Configuration management also gives me visibility into things like the users and groups and all the clusters that are connected. So this can be a way for security teams to understand the level of access, the example users, and what kind of roles they're assigned within clusters. This refers to Kubernetes users and groups that you might be managing in OpenShift. Other things in here include visibility around secrets. Where the secrets are not opaque, we're able to determine the type of secret that those are. Again, this is more informational. We do not display the contents of secrets, so ACS can't be used as a way to override RBAC rules and be able to provide potentially sensitive data to the user here. The risk page is actually a great way to get started with ACS. If you're not sure what you're looking for in terms of security risk in your environment, the risk page is a great place for ACS to present you with an opinion of what it thinks is the risk. Risk priority is calculated pretty simply. We look at all the policy violations, right? These are the default or my custom system policies that have a severity associated with them. And you can think of severity as a score, where critical might be 5 points and high would be 4 points. And all these points get added up, and the highest one wins, or rather, the highest one is the highest risk. There are other fixed attributes, so these are not configurable, but we take into account how many CVEs and what their criticality is, whether or not the service is configured in a way that meets hardening standards, how reachable a deployment is. And reachability is a good example of ACS's multi-factor risk. If, for example, there's a new vulnerability discovered in containerized software in Java, let's say, or in Python, that vulnerability is going to have different risk depending on whether the deployment is listening on the network. So a remote code exploit really can't function as easily against an unreachable service. And so my front-end services, those things that are listening on the network, are the ones that are more reachable, that have a higher risk of that exploit occurring in the first place. Other fixed settings here include things like what we call components useful for attackers. We see attacks where upon a successful breach of a vulnerability, the attacker lives off the land, right? Makes use of the tools that are installed in the software, things like package managers, shells, transfer tools like curl and wget, to explore the environment, to attempt to access other systems, exfiltrate data, to maintain and establish and maintain footholds in the environment, create backdoors. So they're highlighted here because there are system policies that encourage developers to remove these tools, or better yet, to start with base images that don't have them. The discussion of risk goes much deeper than that. There's quite a lot here, but let's move on to the next section. Of all the sections in the platform configuration menu here, you're probably going to spend the most time with policy management. And again, there's a more detailed video on the capabilities of the policy engine here, but a couple things to note about the UI. I have a list of all the policies here that I can expand to understand the capabilities. And of course, as I click on them, you'll understand what the description and the guidance is for each one of these policies. All policies in ACS are written in this way with and help the recipient understand what's wrong and how to fix it. Hopefully that helps them move towards more secure, lower risk creations. You'll see that there's an actions button up here where I can edit or clone. Cloning a policy is recommended if I want to make changes to a default system policy. I can also export that policy to JSON, and here on the main policy management page, you'll see a corresponding import policy. The bulk actions drop-down menu here is disabled by default until I select one or more of these. And the bulk actions can be used to enable or disable those policies in bulk, or be able to enable a notification. If I choose notification and I decide that I want, for example, to send this to my Ansible event-driven architecture server, I can bulk enable all of those, and they'll all be updated in one group here. You'll see that many of the policies are disabled by default, some of them because they're more advanced topics, some of them because they really exist just as examples. Some of them are good practice, like this one, for example, but it's not something that you typically tackle on day one. These are more advanced hardening standards that are recommended, for example, by the Docker CIS benchmarks, which we have policies here for. Many of the policies are linked to things like compliance standards in the compliance user interface. Some are also linked to the MITRE attack framework. And your custom policies, you can do this as well, where you're linking the attack to the tactics and techniques that the policy is designed to detect or to prevent. Okay, let's talk about searching and filtering. Searching is a really powerful way to understand how impacted you are by, let's say, a new security threat. Really common example of that is the need to investigate whether your environment is impacted by, let's say, a new or an old vulnerability, right? For example, if I go searching for the log4shell vulnerability, I can find images, deployments, and namespaces where the container image in those objects here has that vulnerability present. So here, for example, I see an old Logstash version. I can click on this to find the image. I can also go and take a look at the Logstash application that's using this in my risk view. I can search for anything here. I can search for images. You can see some of the keys here. And the search UI works this way almost everywhere. So as I filter, you'll see that I'm required to select a key. So it's not just a generic, type in a value that I'm looking for. First, I select a key that I'm going to be searching in, and then I can search for the string that I'm looking for. So I can also start typing these here. So if I'm looking for process activity, as I begin to type this, the UI will show me the available options. Now, when I have a result like this, process name, for example, is of course looking for strings, the name of the binary that would be running. And so I can look for everything that's running Java. Now, the process name doesn't necessarily have to just be a string here. Many of the filters will support regular expressions. Regular expressions are a wildcard matching language, I would say. There's quite a bit of complexity here. To make a search a regular expression, I can use the R and a / to indicate that this should be treated as a regular expression. And so now, instead of just looking for a process called log, I can actually go out and look for anything that contains the string log. Most of the pages outside of the global search also have filters that are appropriate for those pages. So for example, in violations, a really common way to search this list of 200 here would be instead to go and look for a specific namespace where I want to isolate this down. This filtered view is a little bit more manageable. It helps me zero in on the risks. Speaking of risk, the risk page also has a similar filter where I can search through all of my running deployments to find, for example, who's running Java, who's running a shell or something else. And all those things, these data here gives me that short list here. As I drill down, you can see that over here on the process discovery under the runtime results, I am indeed running Java here. What I like about search filters in this page is that I can use the search results, the filter results here. For example, show me all of the pods running Java that are exposed internally in the cluster, and then I can create a policy from that. So this is something that allows me to hunt down the characteristics that I'm looking for and then create a policy directly from that. So that's it for our tour of this UI. Stay tuned for more videos on more capabilities like command line and API. Check out the other videos that we've already created on topics like vulnerability management and system policies. Look forward to seeing you on the next one.